Okay, let's do Advent of Code Day 4. Scratch cards. The gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches you into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello, the elf excitedly runs over you. How may I be of service? You ask about the water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have though. This is Island after all. I bet the gardener would know. He's on a different island though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I've got all these scratch cards as a gift, but I can't figure out what I've won. Hey Sunco Software, good morning, thanks for joining me. The elf leads you over to a pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers separated by a vertical bar. A list of the winning numbers, and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear on the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of the card. I'm glad I caught your stream. Well, I'm glad you're here. Thank you. And the love handles. Welcome. I don't think I've seen you before. Thanks for joining the stream. So here we have the example data. I still have to read it. I think these were the winning numbers and these were our numbers, but I'll have to check again. In the above example, card 1 has 5 winning numbers. Okay, so these are the winning numbers and the 8 numbers you have. Okay, of the numbers you have, 4 of them are winning numbers. That means card 1 is worth 8 points. 1 for the first match, then double 3 times for each of the 3 matches after. Okay, 1, 2, 4. Wait, what? Okay, for every number your score doubles. Okay. So it goes 1, 2, 4, 8, 16, etc. Okay, so it's like bit shifting actually. 4 of them are winning numbers. That means card 1 is worth 8 points. 1 for the first match, then double 3 times for each of the... Yeah, okay. Okay, so every time you have one more match, you double your value, which is basically just bit shifting 1 over. So I think that's the way we will do this. Let's see, Sunco Software says, today was much easier than yesterday. I haven't done yesterday's puzzle yet. I always struggle with the parsing. Yeah, I can imagine. It can be a pain. Though, in this case, it's basically a 2D grid, right? So if you go character by character and then map it out, I always struggle less with those kinds of things. I think the day 2 was more hassle parsing for me personally. So let's see, so we have some examples here. So in this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful cards. How many points are worth in total? Okay, so let's take the test input. And let's duplicate our base class and make this day 4. Day 4. Boom. Put this, and we override our automatically pulled input. Let's see, let's make sure that we also run day 4. I should probably just make this automatically based on the current day number and then add an override there if needed. So yeah, let's see how we parse this. So there is a separator, so const char data separator. equals that one indeed. And we can also do header separator equals almost correct. By the way, if you haven't seen one, I have a video of this autocomplete coming up short when trying to count. It goes like 2, 4, H, I, J. So it's it's funny. You always have to watch out what it suggests for you, but it tries to help. So let's do input.toLines dot select x blah x dot split by, and this will be the header separator, and then we'll take this part because we don't care, then we split that again. Actually, we can just do it like this, split by, and then I'll use this one. Like data separator. Okay. Lol, seen it. Okay. Let me see. So this one will turn it into a set of pairs. And I actually can do the as yes, so I can do x dot split space dot select x. Bim. Oh no, this will be y. Bim. As ints like this, and then I need to add another one. I need to separate this because it gets too long. So we do this, and here we split it, and then we split by that to an array, and then we cast it. So I hope I haven't lost you yet. And this will be, is an IEnumerable? No, it's a list, so that's fine. And then for the second one, we can also do x dot, we can actually do the same as this one. So this is my own helper function, and it will basically just make sure that we get a value tuple out of this. So parsed equals this, and now parsed should hold like a list of with a pair of two ints. I can also do this to list, so it's not IEnumerable. So now we have a list with a value tuple that contains both sets, and actually I can do it like this: new hash set int, like this. That is even better because we will have to look up one in the other. This can just be like that. It doesn't really matter. It doesn't have to be a hash set. So now parsed. We can do for each parsed. Int points is 0, and we do for each var num in x dot item 2, and what I can do here is actually give them names. So if I do list and I do hash set int pulled numbers list int my numbers. Now my parse thing will be named, so now I can do pull for each in my numbers. So now I can enumerate through this. Have you benchmarked your solutions? No, I haven't yet, but I don't think there's anything that runs more than a millisecond or something. I doubt if it even runs for a millisecond. So far everything has been very fast, but I'll be sure to add some benchmarking after. Let's do it like this. Now you're making me conscious of every little micro optimization that I can do. So we do here if x dot pulled numbers contains num, and then we do points. We shift it one to the left, so we double the value. So now we can do console.writeLine. Yeah. And I haven't parsed the name here, so we do. I'll just dump out the point values here, points, and this will be points. So I'll just run this now as a debug. So this should give us our values. Do I have an infinite loop here or something? That is useful. Input string was not in the correct format. What is the value here? An empty string. Oh, that's okay. Call stack. Let's see. Because these are split. I didn't trim them. Okay. So I can do actually try as into skip empty. Let's clean it up like this. I should probably just I'll just do it like this. Boom. Is that better? Okay, great. It doesn't work. Let's see what it comes up with. Boom, 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 boom. So parsed. Let's quick watch it here. So that's 41, 48, 83. Okay, that's correct. Part 2 is those values. That is correct. Okay. So what is the issue? My numbers, which is the value here? 83. Okay. Okay, my bad. Can I do one? Yeah, that's true, because you can't shift zeros because it won't help here. So so the points is 0, 1. So let's do it like this. So this should work now. Let me actually run it without a breakpoint. See, and these are the simple mistakes that you make that can cause you pain if you don't catch them in time. And that's why I always like to print out as much as possible. So let's see. We have 8, 2, 2, 1, 0, 0. Okay, so let's run this against the real thing, and we also still need to sum it. So we do long sum is 0. I can also just put it in a checked int, but as I said before, I think I said it yesterday, I like to do it this way. Do sum plus equals points. And do console.writeLine. Comma, writeLine. And then we call this part 1 sum. So we don't print it out every time here. And now we need to disable the input bypass and run it like this. Okay, here is our value. As you can see, no need for a long whatsoever. And woohoo, we're 1 gold star richer. So let me take a sip of my cappuccino before I go on to part 2. Sunco Software says, get it to work, then worry about optimization. Never! No, I always try to refactor while I'm coding. So if I see something that I think should be improved, I always try to do it as I'm going along. So like once I catch myself copying code and duplicating it, it's like, okay, maybe I need to rewrite this already. So usually when you see me coding, you see me constantly refactoring as I go along. I don't obsess too much about the performance, but I always try when I write loops, etc. I always try to make sure that any working variables are declared outside of the loop. It's just a habit. So I usually, while I work out my code in my head, I'll start typing, and then once I settle on the solution, I'll clean it up, move variables out of the way, etc. It's just, yeah. Okay, let's read part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scorecards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So, if card 10 were to have 5 matching numbers, you would win 1 copy each of the cards 11, 12, 13, 14 and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. Okay, so if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same card that the original card 10 won, cards 11, etc. Okay, this process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Okay, this time the above example goes differently. Okay, so I need to read this again probably to understand it fully, because in my mind what I would do is take note of the amount of cards and then have like a multiplier set for the following indices, so that I would just process everything as normal and then multiply it by the multiplier. But yeah, let's see. Card 1 has 4 matches, so you win 1 copy each of the next 4 cards. Your original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Your copy of card 2 also wins 1 copy of cards 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers, so you win 4 copies each. Okay, so the thing that I had in my mind, I think that just works. Your 8 instances of card 4, the originals have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies have no matching numbers, so you win no more cards. Your 1 instance of card 6, original, no matching numbers, you win no more. Okay. Once all of the original and copies have been processed, you end with 1 instance of card 1, 2 instances of card 2, 4 of card 3, 8 instances of card 4, 14 instances of card 5 and 1 instance of card 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you end up with? Okay. So yeah, I think I understand, but you never know. I'll just copy it for now, because what I want to do is actually, and it will just keep track of how many extra cards you won. So dictionary int multiplier. So what I want to do is like this. So now we do for int sub is 1 sub smaller equal to points. Oh no, it's not points anymore. This is just this will become dupes. This becomes just plus plus dupes. Like this. So now we add if not multiplier, that's try get value x plus sub. Why is it complaining here? Oh, x bumps. I need to keep track of the index actually, so this needs to be a for int loop. For int I is 0, I smaller, yes, plus I. X is, no, x is plus I. Like this. Okay. So this becomes I plus sub. Dun, 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 dun. Yeah, actually that's exactly it. And we also need to make sure that we I think in the end we just count these multipliers. Let me see. And here we do dupes. No, we also need to do this. If multiplier try get value I out var local multi dupes like this. I think this is actually the logic already. We don't care about the sum anymore. Actually we do. This just becomes a count. We probably need to dupes larger than 0, dupes, and otherwise it's 1. So if it has any dupes, it will be that multiplier. No, wait. I will need to debug this because I'm getting lost in my head already. So let me just run this and see what comes out for now, because I need to go through it probably just to make sure. So that says 15, that's not correct. Let me just go through this for now. Not like that. Also, I think I just need to increment the count already for this one. So it would be, for this one we have this. No, I need to do that here. because this tells us how many times we process this card. No. If I just run this, does it give me 30? Let me see. No, not at all. Okay. Let me just make sure that I do this right. Let's see, in this case, dupes is 4, so that is good. Sure. So we do this for each one that exists. So now multiplier for the next one gets set to 1. And I think if I run this to the end here, we'll have 4 entries for 2 to yes, for those indices, and they all get 1 multiplier. So that is good. Now we have the next one. It has 2. I do this wrong. This is correct. The dupes thing is correct, but I need to have a local multiplier. So local multi. How we do this is 1. 2, 2, 2, 2, 2. Okay. I can just do this here actually. In this case that one is set, and I need to do it plus equals this one. Let me just step through it here and see if this is correct. Actually, let me run it once and another time. So now there should be, so 1, 2, 2, 1. Okay, is that correct? I think so. Ordinary card is too much, now must you win 1 copy of each card 3 and 4. Yes. So I think this is now correct, because these one get an extra 1. Local multiplier here is 2. So then I think those will be 3 and yeah, okay. I think so far so good, but this goes up to 6, we're at 3. Oh, I ran too much. That is 16, that is still not correct. Put on. Let me see what I'm doing wrong. Let me think. Let's see, 4 instances of card 1, yes. Ah, wait, this is wrong. No, this isn't wrong. This is actually how much there is for the current card. That's interesting. Let me put it side by side and see where my thoughts are not right. So first we have 1, because the first card you have once. It will add 4 more. Does it run till here? Okay, so multiplier. So now we have, it gets set to 1, but that's not correct. It needs to be, if it doesn't exist, it needs to be set to 2 actually. No, let's see. This is tricky because the default should already be 1. So if you pull it, the smallest value that you can add is 1. Yes. So if you add it, it needs to add the local. Okay. Let me see if that is correct. 30. Okay. There was the bug. Okay. So, what I did was I kept track of the multiplier. But my issue was I started it at 1. But when you start to add a multiplier, it's 1 more than you should have. So the default should be 1 already. So if you add more, it should start at 2, right? So in this case, when we don't have an entry yet, we need to start it off as already being 1 and then adding that multiplier that we have for it. So, okay. Let's see if this works for the final input. I'm not fully confident, to be honest, but that's just because it takes a bit to wrap my head around it. But it's correct, it's the right answer, so yeah. Whew. That second one got me a bit sweating for a bit, but yeah, we managed to pull the gold star. That's nice. Fairly smooth, just minor debugging. So yeah, let's see. The code is actually not that large. It's fairly compact for what I write. But I must say, like, my own extent, at least I like the way I'm doing it. This extension functions that I wrote, it really makes it a pleasure to just parse the data and work with it, because I can just, like, the 2 lines, it's all not rocket science, but when you put it all together, it just gels, right? So this as that I made, if you just declare the type, you get it nicely structured, named, etc. So this might look a bit iffy, but yeah, it works well, I think. So yeah, maybe it's time to pull out the benchmark, but I won't do that now. I'll probably do that tonight. I think I'll continue with the other work that I have lying around. Still business to run, but cool. Suncoast Software says, I use your extension class. Well, thank you. I really like to see that. I think I also added more stuff, so I should probably, that's something that I should do, is just make a public GitHub repo and put all my stuff in there. I still haven't done that because for some reason I always stick with private repos. So I'll also see if I have some time. I will try and see if I can put it together, because I also have like extra code to extract, like to copy the Chrome cookies from a running process and then extract the secure cookie to get your Advent of Code session key, and then the base class to pull in the input automatically. Okay, cool. So, and I should probably pop out the chat next time and just have it like on screen here. So yeah, I'll be sure to do that. So yeah, I want to thank you for keeping me company today, and maybe I can see you again tomorrow. So thanks, and feel free to drop your code in the Discord and I'll take a look at it later. Bye for now.